All right, I'm going to move on and spend a bit of time around our VMware virtual volume integration. Again, my name is Ben Bowles, Vice President of Products here at NexGen. Here to talk about the NexGen VMware virtual volume integration that we have with version 3.5 of our software. So virtual volumes is something that we've been working on for a while with VMware, and we really see the marriage of our storage quality of service, being able to do that on a storage policy within VMware and assign that to a per VM granularity. And so doing things around provisioning of virtual machines and a lot of the advantages that virtual volumes brings to the table is goodness. And with our integration, we see some advantages where we can kind of take it to the next level around being able to achieve better consolidation. We can host multiple virtual machines on the same storage array, so there's no separate silos of storage, whereas an alternate approach would be to have different types of storage systems that have different capabilities. We can also deliver VM granular QoS, so have that predictable VM performance, and then it's all simple policy-based management, which we'll get through here in a moment. The way that our virtual volumes is implemented is it's a VASA 2.0 provider that surfaces through our rule set for quality of service, surfaces those QoS policies within vCenter. So the VM storage policies, there's two defaults, virtual SAN default, and then a no requirements VVOL policy, and then our 5 policies map to storage or VM storage policies within vCenter is kind of how we set that up. From an architecture standpoint, there's a lot going on this slide. So I'll walk through some of the different components. So the NexGen N5, there, that box there on the bottom left. So we're an active storage processor design, and so a couple things that come out of that. We have a VASA provider that runs on each storage processor. So we have the high availability for the VASA provider. You register that within vCenter. And then there's a protocol endpoint running on each storage processor as well. And that's the protocol endpoint is what the ESX servers are going to connect to, and then that's how we present up the virtual volumes. There's on our NexGen N5, there's 2 storage pools, one for storage processor A, one for storage processor B. And then we map those to data store containers within for virtual volumes, and I'll show you how that's done here in a moment. But it's a one-to-one mapping, so you end up with 2 data store containers, out of which we provision virtual volumes. Some of the other features that we have around the capabilities, we've talked a lot about quality of service mapped to storage policies, giving you that software-defined performance. You can change these on the fly. It automates the VVOL provisioning. We also have our snapshots and cloning, the thin snaps and clones hooked up. That's part of the virtual volumes specification, that you have that capability. And then performance from a virtual volume to a standard volume for us is equivalent. So we've done those measurements. And then as far as the VVOL addressing, most of you are probably familiar with this, but the protocol endpoint is what we call an administrative LUN. So that shows up as a special LUN for the ESX host, and then it's the sub-LUNs or subsidiary LUNs that are the virtual volumes that get created behind that.
So is this array a Lua?
We do MPIO Lua to specify optimized and non-optimized pathing. And that, with virtual volumes, that's all configured and set up now through the protocol endpoints. I'll go through a set of demo slides here just to give you a flavor for what our VVOL's integration looks like. So, first step is to register the VASA provider. You specify the IP address of the storage processor and give it some credentials, and then that brings it online as a VASA 2.0 storage target available for virtual volumes. Then we go through and we create the data store containers, and so this is where I mentioned before we map one to each storage pool, and then those are brought online and become a virtual volume data store within vCenter. The next step is we go through and we set up the storage QoS policies, and so within vCenter we map the VM storage policies. So here we've got a mission critical policy 1, which is going to map to the NexGen storage mission critical policy 1. So it's a QoS rule that's surfaced out of our VASA provider, and then that gets configured and then is available as a storage policy that can be applied to the data store container. But really what we're going to do is we're going to apply that to the individual virtual machine. So when we go to deploy the virtual machine to virtual volumes, this is when we're here at the select storage dialog. We're going to specify what storage policy we want this particular virtual machine to belong, and then that's going to provision out. Here we're putting in mission critical policy 1, and then that's going to provision out. At a minimum, it provisions out 3 virtual volumes, 1 for data, 1 for config, and 1 for swap. And then those are presented within our user interface. But really all the management is done within vCenter. So this is more of a view from the storage. And then you can also specify, and I know the question came up earlier about, can we go down to an individual virtual volume? And this is the screen where you do that, where you could set a different storage policy for the virtual machine, and then customize if you had, different virtual volumes. They can have different policies, and then we'll automatically adjust that on the NexGen storage. Protocol endpoint, pretty straightforward. That's the NexGen iSCSI LUN that gets presented as the protocol endpoint, and then the padding associated with that. So you see the MPIO Lua active paths for I/O versus non-optimized. Okay, any questions about our virtual volumes integration?
Mine's not about virtual volumes. What do you guys support for fabric between? You guys have specific requirements for fabric. I saw that there's four 10 gig ports. I'm guessing 2 and 2,
So you can do a single iSCSI fabric or dual fabric.
Okay. You don't care what switch vendors, as long as it passes traffic?
We have a list of recommendations as far as your switches need to be kind of up to these capabilities.
Okay.
For 10 gig operation and performance and
Cool.
high availability, that kind of stuff. Okay, one sometimes questions come up about, well, this is all great around vSphere 6 integration and virtual volumes. What's the migration path look like? And so it's really a 3-step process. The first one is to upgrade or deploy the technology for VMware and for NexGen that enables virtual volumes. And then the second step would be to configure the VASA provider, the NexGen VASA provider, and then set up the storage QoS policies. And then step 3 would be to deploy the virtual machines. If it's an existing virtual machine, it's a simple storage vMotion. And so in this example here, we would select a virtual machine and then migrate it with storage vMotion, and then it automatically provisions out the virtual volumes and constructs those on the VVOL storage container. It's other note. Sometimes you get questions around VAI support. So the NexGen product supports VAI. So if you do this storage vMotion on, from a data store, BMFS data store on the NexGen array, and then you want to go to virtual volumes, it'll be offloaded, Xcopy offloaded with VAI. And the way that this looks, pretty straightforward. It's located on this VM's located on a VMFS data store. It's got the traditional VMFS layout, and then we're going to do a migrate via storage vMotion and change that storage. And then we specify for the storage that we want it to go to a mission critical policy 1 for NexGen QoS, and then that categorizes the two data stores for virtual volumes that would be able to support that policy, and then it does that migration and creates the VMDK virtual volume objects on the backend storage. And you can also go in and change these on the fly. So in this example, we'll change it to business critical policy 3, and then that changes it on the virtual machine, which subsequently is changing it on the storage. So you have that end-to-end linkage and connection from storage policy management within vCenter to the QoS policies on the NexGen storage. Okay. Any questions for me about the VVOL's integration or any of the other QoS topics that we've talked about?
Ben, I want to circle back to the QoS. There's a little bit of sort of by discussion. I was thinking about the QoS. If all the writes are always going to Flash, then the QoS policies are just saying how aggressively are we going to use the Flash for reads. There's essentially what volume of Flash is going to be allocated for this object in the read. Is that essentially what the QoS policies are covering?
No, it's
more?
The QoS engine is at the top of our stack, so it is doing prioritization and queuing on the top even before the data lands in Flash. So it's a pretty multi-variable, pretty sophisticated type of an algorithm.
The rabbit hole goes much deeper than you've been able to show us.
It does, but it has the metrics built in, the policy management built in. It has the prioritization built in, and then the caching. So those, trying to give you a view of the different elements that are there. So to your point about all writes going into Flash, that happens for volumes that are mission critical, business critical, non-critical, and then the aging of that data out of Flash is also determined by QoS. So we're a hybrid solution. So meeting those quality service metrics is largely determined about how much data is in Flash versus disk.
Is there a way you use the RAM actually in addition to the Flash?
Mm-hmm.
Or is just
we use RAM as a read cache.
read cache?
Correct. Okay. Any other questions?
So does the read cache also step into the write cache? So if I have like active blocks coming in and they're hitting the write cache, and then their system wants to read them again for, say, a report or something like that, will the read cache step into the write cache, or does it have to be staged down first and then brought up?
No, you can warm from disk or from Flash.
Okay, so the read
RAM.
cache will be warmed from the write cache.
Correct.
In certain QoS policies.
Right.
Okay.
Yeah, that's a good question.
But if your mission critical quality service level is not being met for whatever reason, new writes from non-mission critical systems will still hit flash, or will they skip that tier
In the
altogether?
current revision of our software, all writes are going through flash.
Okay.
Bypass flash is another capability that we're looking at, and whether to make it explicit to just a non-critical low-level policy doesn't get any flash, or more dynamic to adjust those types of things.
Okay.
Well, more
Definitely looking at that.
more dynamic would be cool because
Right.
if mission critical isn't using all of that capability, you'd like the performance of everything else to go up as
Right,
well,
and that-
right? But when there's contention, you want your mission critical stuff to
Right.
always take precedence.
Right, and that's been our philosophy from the beginning with our QoS, is especially with our target customer in that small to medium enterprise or mid-range customer, when they want to be able to take advantage of the performance when it's there, and then we will dynamically cap the non-critical and then business critical if we need to.
But then again, like a backup system, people run Veeam or something like that, that will just, skipping cache completely might be a way to go, because all that stuff does is bust cache and,
Right.
just run it straight to spinning disk and be done with it, So maybe it's just deciding what because you've got two policies there in non-critical, right? Maybe that lower one just never gets cache, and the upper one does. Or
Yeah,
something.
that's something that our customers have asked for as well.
Yeah.
Have some more granular options there for how the system will operate.
It's a balancing act. You guys said up front that you guys are aiming at the small and medium business segment, and I think this is amazing for a small and medium business. This outclasses a ton of other enterprise level stuff as far as having QoS and doing
Yep.
stuff about it. But I forget where I was going. Excellent. So
Thank you.
whatever. So.
Does the array do compression in dedupe? Maybe you covered that.
We have a data reduction engine that's inline. It's inline on ingest. So it does both I/O and capacity reduction on the front end.
Is it compression, dedupe?
It's a pattern match, so it's more like compression.
Okay.
It's not. We don't have a post-process dedupe.
Okay.
Okay.
Cool.
Thank you very much.
And before we go, there's a lot of questions about contention and what happens. We've actually got a scenario that I'd like to show. So if you let me pull up one slide real quick, I'll show you that specific scenario because we have tested for that. So give me 1 second. Okay, so this is, there's a lot of discussion before about Ben showing the prioritized active cache. We did an experiment to show, how you can just give a VM more horsepower, and over a span of seconds to minutes, you over 10x the level of horsepower that VM has from a workload. But then the question came up, well, what happens when there's contention in the system? And this is really important too, because it's beyond mins and maxes. There's always times, especially when you over provision your infrastructure, which is a smart thing to do if you want to take advantage of it and utilize the resources the best that you can. What is the system going to do in those situations? And that's exactly what our service levels do. So when we talk mission critical, business critical, non-critical, that's the intelligence that the system has to make choices when there's contention in the system. So this example shows a screenshot from our user interface where we were running 3 workloads, and we had them categorized, one in mission critical, one in business, one in non-critical. And then we inject a second business critical workload, and you see that spike. The impacts are, you don't see any impact on the mission critical workload. Completely consistent. Where you see the impact because of contention is we're auto-throttling the non-critical stuff to meet the goals of that business critical workload. So you see us shave that off so that we can achieve the quality of service for that fourth workload that we kicked off. We ran this exact same test on a leading SSD-based hybrid array. Same exact workload. We had to pull it back. It's not to the same level because the PCIe affords us a lot more headroom and performance. But we ran the 3 workloads on it. We kicked another one off. You see that gray line, and then you see the degradation on the other workloads. That's contention in that system. And you see a 23% impact on mission critical, 30% impact on the business critical, and a 27% impact on the non-critical workload. This is really this is why you need 2 different concepts in a quality of service engine. You need the target, how fast do you need to go, and you need a priority scheme so that the system can make the right choices under contention. Because if you don't do that, then you limit yourself in, then you can't over provision, or you're going to get in the scenario on the right, and then quality of service, I don't care what sort of mins and maxes you have. If you've over provisioned, you're still going to be exposed to that scenario. So prioritization and performance targets are kind of the 2 elements that you really need in a really robust quality of service engine.
How much flash? How big? If I wanted one of these things and I wanted it huge, how big can your arrays get?
The biggest starting block we have is 15.6 terabytes of flash and 64 terabytes of disk, and that would be in a 3U footprint. You can scale that to 256 terabytes.
256 terabytes of disk?
Yeah.
Okay. And 15.6 terabytes is the largest amount of flash you can have, period?
Today, in one of our domains or systems, yeah.
What's the smallest array I can buy from you guys?
A 2 terabyte flash, 32 terabyte disk.
Also in 3U?
3U, yep.
Okay. Thank you.
All right. Anything else? I know we talked about this one. I wanted to pull this slide back up and make sure that we hit that because we do test for contention. It is important. It shows the other element, the other side of quality of service. A lot of people don't talk about.
This is instructive. Yeah.
Okay, so I think that's all the content that we got through. So we're gonna preserve 45 minutes of your time today. We really appreciate the audience, and I know the storage arrays isn't typically what you guys see, but we hope this was useful and instructive. And I think it's kind of an indicator, a leading indicator of where all infrastructure is going when you start seeing, storage vendors deeply integrating with VMware, with vSphere 6. There is a lot happening in IT, and this is just one example of where everything's headed.